Welcome to the second topic of Module 5, Soil Examinations. We will begin by defining soil, and then we'll also discuss the investigative information that can be obtained from soil samples. We'll discuss the various analytical tests that are performed on soil samples in a forensic laboratory, and then also the methods of collection and packaging for soil samples. If we begin by defining soil, soil is commonly thought of as the outermost layer of the earth. It's going to be composed of a wide variety of different materials, such as rocks, minerals, even liquids, gases, and organic matter. If we look at this example, it shows you the breakdown of soil samples. So you can see there is a little bit of water, a little bit of air, but the majority of the soil sample is going to be composed of mineral particles and organic matter. These are the things that are going to interest the forensic scientist in their examination. Soil can be found as samples in criminal investigations in a wide variety of circumstances. Someone could walk through soil, leaving shoe prints. You can also have vehicles that would be going through soil, or commonly also soil may be examined in various cultivating marijuana type situations. The examination of soil is going to work to establish associations. So it's going to try to establish contact between, in some instances, a scene and a particular vehicle, or a scene and a particular person, or in some instances, a scene and a particular source. And we do this by the examination of soil samples in a forensic laboratory. So we can learn a lot from the samples themselves. Depending on the amount of the sample, they can be analyzed for their overall color, texture, density, elemental, and mineral content. We initially start by examining the physical properties of the soil itself. The physical properties include the texture of the soil, the color of the soil, the density, the elemental composition, and the mineral content. So if we begin by talking about each of these individually, the soil's texture can take on a lot of different forms. You can have soil samples that might be extremely sandy, soil that can have more of a clay particle basis to it, some of them that might have a lot more gravel into the soil. So the overall texture of that soil is actually determined by a field test, where the analyst is going to take a small amount of the soil and actually put it in the palm of their hand and just feel that overall texture and describe that texture. They're also going to work with the color of the soil itself. Soils, as you can see from this example, can have very differing shades of color. When they look at the color of the soil, it's very important to make sure that all of the water is out of the soil, because this can cause the soil to have a darkened color. So when they begin their analysis, one of the first things that they will do is to actually dry out that soil sample to get rid of all of the water in the soil so they can see the true color of the soil. They're also going to take into consideration, once again, the texture of the soil and the color of the soil after they have sieved the soil samples into different portions. So they'll use a series of different sieves to get the very small particles separated from the larger particles of the sample itself. Then they'll also use some of these portions to do further testing on, whether it be density testing or elemental testing and the mineral content of the soil itself. But initially, once that soil is sieved, they will look again at that overall texture and that overall color and do a little bit more notations specifically for each sieved section. Once the sieve sections have been collected, one portion will be used to determine density comparisons of the soil sample itself. Before the density or elemental or mineral composition can be determined, that sieved portion must be cleaned up, so that you're looking specifically just at the minerals themselves without adhering dirt to each particle. Since density, as we learned in the glass lecture, is a physical property, it can be used to help characterize the soil samples. In glass comparisons, we had a single component that was being compared, just that glass particle. In soil comparisons, we're going to be taking a sample of that soil itself, which is going to be composed of a variety of different components. So we will use density gradient tubes that will distribute the different particles of the soil according to their density. And you can see this is a good example of the density gradient tubes, and you can see how the various minerals, whether it's a hornblende mineral or a mica mineral or a quartz mineral, how they will distribute themselves according to the density of the mineral itself in the density gradient tubes. So you would use a single tube for each sample that you are wanting to compare. The mineral content is also examined from the soil samples. This is also performed on a cleaned section from the sieved samples, and the refractive index is determined for those mineral identification. This is usually done with a special objective that's put on a compound light microscope. Another thing to keep in mind with soil samples is that they may have very unique and identifying particles within that soil itself. So originally we talked about soil samples with cultivating marijuana type situations. It might be where the officer is needing to identify various fertilizers that have been added to that soil to prove cultivation. So you might be identifying different particles out of the soil itself. Always keep in mind too, there could be, paint flakes that have fallen off of a home or brick particles that might be contained within that soil sample. So in addition to the soil itself, there might also be other components that can actually be compared and analyzed. You can find soil evidence also in a wide variety of crimes. Remember, it is going to be easily transported because of the fact that individuals may walk through the soil or vehicles may go through the soil. It's usually going to be easily detected because generally soil samples are going to be larger samples. So usually just a good light source can also be used to identify that soil. In some instances, for a lot smaller samples, you might want to use the aid of a stereo microscope in detecting or collecting your samples. However, in most instances, it is going to be that you can make the collections with your naked eye, because for soil samples, it's going to take a little bit larger quantity to actually perform a complete analysis. For foreign soil samples, you typically want the sample to more or less cover the palm of your hand. It's necessary to have a larger sample because when cleaning that soil sample, after you sieved it into the various portions, you've reduced the amount of the material that you actually have to work with for the density and for the mineral comparisons and identifications. So you initially have to start with a much larger sample. Like I said, you want to have the soil to cover the palm of your hand for any foreign samples, to have an adequate amount to do a complete analysis. And also with known samples, you need to have more variety to the knowns. Since soil can vary even within small areas, you want to attempt to take a known sample from the point that you actually suspect the transfer occurred from, but then also from several surrounding areas. So you might want to take also a soil sample from either side of that suspected origin about a foot away, and then once again about 10 feet away from the point of origin. This gives you more information for the elemental type distribution that might be found in that area. You should also keep in mind that you want to take the soil samples only to the approximate depth that's actually necessary. So if it is a shoe print that went down into the soil about an inch, that's about how far you want to take your known soils down, only to that inch. If you dig down and take soil samples 8 inches into the ground, the mineral content can vary. For your soil samples, for your foreign soil samples, a lot of times these are going to be collected off of the bottoms of shoes or off of tires, and you always want to try to remember to use the most direct but also the least intrusive method. For soil, most often you're going to be scraping the items out. So along the bottom treads of the shoes themselves, trying to get that trapped soil out of the treads or out of the treads of tires. You always need to look for different foreign debris that might also be contained in that soil sample. Remember, with scraping, you're going to know the general location that you actually collected that foreign sample from, but at times it can be a little bit more time consuming, and depending how careful you're being with the scraping, you can damage some of the foreign material that might be embedded. There's a lot of different packaging material that can be used for soil samples. In most instances, you're going to want to take into consideration that your soil may be damp, so you want to put it usually in something that's going to be a paper container so that it can continue to dry out. If you have to use plastic bags or small little metal tins, you want to make that lab analyst aware so that they can open it up as soon as it gets to the laboratory so that it can continue to dry. With soil samples also, you need to take in mind that you're going to have to keep this secure. Since some soil can be very sandy, once it starts to dry out, you want to make sure that any seams in any envelopes or paper containers that you're using are going to be sufficiently sealed. And this is going to usually be done, once again, with tape, and then always remember to label that seal. Soil samples and comparisons have been used in courts for many years. The methods used in the analysis have passed Frye and Daubert hearings. That analyst doing the examinations is usually going to report the soil examinations using one of three different terminologies. Either that the soil from the exhibit is different from a known sample, or that the soil itself may be similar or identical to that sample in the various optical and physical properties which they examined. In some situations, the examiner may also have to report that there wasn't enough soil found for the examinations, or that the results were actually inconclusive. This concludes our discussion on soil, and our next lecture will involve hair examinations.